My dear students, welcome to this video tutorial. Before we touch today's item, let me remind you something. In our previous class, we read how to represent the sets related to difference in Venn diagram, and I might have told you while showing the relation between two sets or any sets in Venn diagram, we must have to say the region represented by the given set operation. And if you have not forgotten, in our previous class we solved one problem. There also we have represented the sets in Venn diagram. At last we concluded by shading the region represented by the given set operation. So I know very well the first part. You can easily represent the sets in Venn diagram, but if we have to represent the given set operation, here we are talking about the set operation difference. If we have to represent the given set operation in Venn diagram, we must have to share the region represented by the given set operation. So today we are going to read how to set, because the first part, how to find, we have four fundamental operations: union, intersection, complement, difference. How to find, you know very well. For the second part, how to represent the sets in Venn diagram, that also you can. But the last thing, the main thing, you should know how to represent, how to share the region represented by the given set operation. So for that, today, the first part we are going to read how to set the region represented by the given set operation. Today we are going to talk about how to represent the set related to difference in Venn diagram. So okay, as I have already told you, we have to draw three types of Venn diagram according to the condition of given question. If the two sets are overlapping, we draw this type of diagram. The second, there may be the condition of disjoint sets. Let us say if M and N are disjoint sets, we draw Venn diagram this type. If there is the case of subset, here if N is subset of M, we draw this type of diagram. If N is subset of M, we draw this type of diagram. But today, let us see how to set. Let us consider a set operation M difference in Venn diagram. We have to set M difference in Venn diagram, and we have already talked about the main idea: set the first set, accept the second set. Here, if we are talking about M differential, we consider M as the first set, M as the second set. It means we should set the first set. Set the first set. That means set the first set M. Accept the second set. That means we set the set M. Accept the second set N. Don't forget this idea. Set the first set. Accept the second set. If we have to set the region represented by the set operation M difference N, and by the set M difference N, we set M. Accept the set N. Set the first set only. Accept the second set. So we are talking today about the M difference N. Let us set M difference M in different types of Venn diagrams. Okay, let us talk. Here in our first type, you can do easily see. Here I have drawn M and N. These two are overlapping sets. Here in second figure also, M and N are overlapping. M and N are distant. M and N are distant. Here N is subset of M. N is also subset of M. Okay, let us talk about the first. Let us talk about how to set M difference in the first type of condition. Okay, as we know, M difference means set M without setting the set N. Set the first set M, don't set the second set N. Okay, we can't set the set N. It means set N this much. We set the remaining part of first set M only. So we can't set this much. The remaining part of set M is this much. So while setting M difference N, we set the region represented by M difference N in this type of Venn diagram by this way. Here, this shaded region represents M difference N. Don't forget, set the first set M, accept the second set N. So we can't set N, we can set the remaining part of set M only. So yeah, this shaded region represents M difference N. Similarly, if we have to set, now let us say M difference M in the same type of diagram, same type of Venn diagram. Okay, let us see if we are setting M difference M Then we should consider yarn at the first set, yarn at the second set. That is shade yarn except the set yarn. I repeat, shade yarn except the set, shade yarn except the set yarn. It means we can't shade the set yarn. It means yarn is this much. Then the first set we have yarn here. So the remaining part of set yarn is this much. I point out. We can't shade yarn. We shade the remaining part of yarn. That is, this is the remaining part of yarn. So this shader will represents yarn difference yarn. I repeat, shade the remaining part of yarn only except the shade yarn. It gives yarn difference yarn. Okay, we talked about how to shade yarn difference yarn and yarn difference yarn if the sets yarn and yarn are two overlapping sets. Okay, let us talk the second item. Here, you can easily see yarn and yarn are drawn separately. That means yarn and yarn have no overlapped parts. That means yarn and yarn are disjoint sets. Okay, let us check how to set yarn difference yarn in this type of Venn diagram. It means, according to our rule, shade yarn, don't shade the set yarn. It means shade the first set, except the second set. That means except the second is here we have the second set yarn. So we can't set yarn. This is the circle for yarn, this is the for yarn. So don't set yarn. We can't set yarn. We have to shade the remaining part of yarn. Here all parts here of yarn are remaining. It is don't set yarn, shade the set yarn. This shaded region gives yarn difference yarn. Then similarly, yarn difference yarn. Okay, if we are shading yarn difference yarn, if yarn and yarn are overlapping shades, then do consider yarn the second set, yarn the first set. Don't shade the second set. That means don't shade yarn. That means let us say yarn is this much. So yarn, it means don't shade yarn. We have to shade the set yarn only. I mean remaining part of yarn here, all part of yarn is remaining. Okay, it means shade yarn, not yarn. It means we shade yarn only. This shade will represent yarn difference yarn. Okay, let's start the third type. Here you can really see in the Venn diagram, yarn is drawn inside the set yarn. And it means as yarn is drawn inside the set yarn, it means yarn is subset. If we say proper subset of yarn, it will be better. Yarn is proper subset of yarn. That means if we have to shade the region represented by yarn difference yarn in this type of Venn diagram, we shade yarn only, not yarn. Shade yarn, not yarn. It means we can't shade yarn. Yarn means this much. Shade the remaining part of yarn only. That is remaining part of yarn this much. Now you can really see yarn. We have not shaded the set yarn. We have shaded the remaining part of yarn only. Except yarn, we shaded the remaining part of yarn only. So this shaded gives yarn difference yarn in this type of Venn diagram. Okay, last yarn difference yarn in the similar Venn diagram. Okay, now here yarn is proper subset of yarn, but we should shade yarn difference yarn. And it is according to our rule, we can't shade yarn. Don't shade yarn. Shade the set yarn only. Shade the remaining part of yarn only. It means don't shade yarn. We can't shade the part of yarn. It means let's say yarn this much. But as yarn is drawn, my dear students, inside yarn, we can't shade yarn. It is whole part of yarn cannot be shaded. We can shade only yarn. But here, as yarn is drawn inside yarn, we can't shade yarn. But here yarn is drawn inside yarn. Means we can't shade all part of yarn. As yarn is drawn inside yarn, here we can't shade the region represented by yarn difference yarn in this type of Venn diagram. As we know, shade the first set yarn, except the second set yarn. Except the part represented by the set yarn, yarn cannot be shaded. We have to shade the set yarn only. Except yarn, we can't shade the remaining part of yarn only. So as here in this type of Venn diagram, we can do if elements are given while one yarn difference yarn you can do find some more examples. So if elements are given, do find n difference term, you will get in this set. And in this type of Venn diagram, as here n difference term is empty set cannot be shaded. So let us we talked about how to shade, because in our previous class I might have told you, while showing the relation between sets in Venn diagram, there may be given union, intersection, complement, difference. We must have to say that is represented by the given set operation. And in our previous exercise, previous class, we read the first type of problem. I mean, you can do check the previous class. We read one example. We solved there how to show A difference B in Venn diagram, and we solve only one type of problem. There you can do check that very example. You can do find there we solve one problem. There A and B are overlapping. So today let us start two more types. But the main thing, don't forget M while shading M difference M. Shade M only except the set M. Don't forget this idea. Okay, let's take the second example. So while discussing about first type of problem in our previous class, we have already talked about the problem. But today also you can do clearly see here also we do have two parts. The first part is we should calculate A difference B. Then we have to repeat the same shade operation here, A difference B in a Venn diagram. Okay, so let's say here we have the two sets A, 1, 2, 3, 4. The set B, the elements are 5, 6, 7, 8, 9. Now as we have two parts, first part we should calculate A difference B. The second part we have to represent the same set operation, I mean A difference B in a Venn diagram. Okay, let us calculate A difference B first. A, 1, 2, 3, 4, derive minus sign. Then after 5, 6, 7, 8, 9. And how to calculate difference we read already in our previous classes. We can't write common elements. Okay, let us take common elements. 1, 2, 3, 4 are the elements of A. 5, 6, 7, 8, 9 are the elements of B. Now it's clear A and B have no common elements. It means A and B are two different sets. Okay, as we can't derive common elements, all the elements of A are remaining, because this is the second idea. We can't, as we don't have common elements, all elements of A are remaining. That means 1, 2, 3, 4. 1, 2, 3, 4. A difference B has the elements 1, 2, 3 and 4. Then after the remaining part, representing in a Venn diagram. Okay, before we draw Venn diagram, as I have told you, there may be the case of subset, there may be the case of distances, there may be the case of overlapping sets. If the sets are overlapping, we always draw this type of diagram. If the sets are disjoint, we always draw this type of diagram. There may be the case of subset. We draw the Venn diagram according to that. But one more thing, my dear students, in your previous classes you might have read, if universe set is given, also we draw rectangle for that. If universe set is not given, also we draw rectangle for that. But here except universe set we do have only two sets. But what type of sets are given in the problem? Please do check that. You can do identify by checking their elements. It means A and B have no common elements, so A and B are disjoint sets. That is, if the sets are disjoint, we draw this type of diagram. Here A, B. And in our previous class, I told you always start writing from the common part of A and B, as A and B have no common elements. A and B are disjoint sets. That means in our diagram also we have drawn A and B separately. That means A and B have no common elements. It means in this type of Venn diagram, it's even easier than the first type. That means elements of set A, 1, 2, 3, 4. And one more thing, my dear students, if we have numbers as elements of the sets in Venn diagram, we write dot before the elements, dot, dot, dot. But in our previous class, we solved one problem. Their letters are the elements. If letters are the elements, by the time it's not necessary to give dot before the elements. If we don't give dot here, it may represent cardinality of a set. Okay, next one. Elements of set B are 5, next 6, next 7, next 8, next 9. And one more thing. Here we don't have universal set. But sometimes we may have universal set here. If universal set is also given, we must write down the remaining elements of set. I mean universal set outside the circles, inside the rectangle. But okay, Venn diagram completed. But one more thing is remaining. I have already told you, if we do so, if we do represent the shapes in Venn diagram, we must share the region represented by the set, given set operation in our Venn diagram. Okay, here we have the set operation A difference B. It means we are showing A difference B in a Venn diagram. It means let us say the solution completes after setting the set represented by the set of the set difference B. It is actually set A, not B. Set the set A, accept the set B. Accept the set B means this much. Don't set this much, share the first set A. That means we share this part. Don't set B, share the set A. So A difference B. It gives A difference B. So my dear students, I solved one problem today. Okay, in our previous class, I solved one problem related to this. There you can say the two sets are overlapping. Here today we solve the next problem. Here A and B are disjoint sets. But similarly, you can do solve some problems. There may be the condition of subset. You know how to do the diagram. But the main thing, don't forget to write the elements in their proper places. And at last, if we have to save the region represented by the we are showing the sets in Venn diagram, we must say the region represented by the given set operation in the given Venn diagram. There may be overlapping case, there may be disjoint case, there may be the case of subset, and sometimes there may be three subsets of universal set. How to show the sets in Venn diagram, we shall talk in our next classes. My dear students, okay, after looking this video, I hope you will try to do some problems by yourself. You can do so somewhere. You have many more accesses. You do solve some problems, because in mathematics you must be active by yourself. So try to solve some problems and try to solve, get some ideas. You must solve some problems and you must do try by yourself. Remaining in our next video. My dear students, don't forget to like and subscribe Great TV. Thank you.